I welcome you all for the video lecture. Let's discuss the topic software requirement specification, formal system specification. The core characteristics of a good requirement specification are correct and ambiguous one. It should be complete, consistent. It should be verifiable, traceable, modifiable and ranked, understandable. Then it should be out of the source of truth. Formal system specification, let us empathize it. Ambiguous natural language requirements, misinterpretation of system behavior, frequent requirement changes, errors discovered late in development. So let us define how can system requirements be specified without ambiguity, how to represent system behavior mathematically or logically, how to ensure correctness before implementation. Ideate part. We can do so by using the mathematical models, state-based specifications, model-based representations, and constraint-based descriptions. Introduction to formal system specification. The formal specification uses mathematical notation to describe system behavior. The goal is to eliminate ambiguity and ensure total correctness. Mathematical foundation uses set theory and then predicate calculus and algebra. We can focus of what system does by removing implementation. That is what we call abstraction, and it allows for mathematical proof of requirements by checking and the proving theorem. Formal techniques, the merits include reduced ambiguity, math has no shades of gray, and early error detection. It finds logical flaws before a single line of code is written. High confidence, essential for safety critical systems. Model-oriented versus property-oriented. Model-oriented approach builds a mathematical model of the system state, whereas the property-oriented define a set of properties, rules the system which must satisfy it. And we can focus how the state changes over time in the case of model-oriented. Whereas we can focus external behavior and interfaces in property-oriented. So examples of model-oriented approaches is the notation, VDM, and B method. And property-oriented method examples are algebraic and axiomatic specifications. So axiomatic specification definition is that it defines behavior via a set of axioms, logical statements that must hold true. Mechanism focus on the relationship between system, states, and operations. The best use is that it specifies data types and reasoning about state transitions. So algebraic specifications defines behavior through the syntax and semantics of operations. Mechanism uses equations to define how operations interact with the other, and best use defines the interfaces and abstract data structures where implementation is hidden. The comparative summary of the model-oriented approach and property-oriented is given here. The primary focus of the model-oriented is the system state, whereas the property-oriented approach is system properties. Then the methods of model-oriented approach is a Z method, VDM method, and B method. And property-oriented includes the axiomatic and algebraic specifications. And complexity is easier to visualize as the model-oriented and more abstract to concise than property-oriented. An application is that model-oriented can be used to complex system logics, and the property-oriented, we can use it to abstract data types. Conclusion, a strong software requirement specification is the foundation of quality software. Formal specifications provide the highest level of precision and reliability. The choice between model-oriented and property-oriented depends on whether you need to track internal states or external behaviors. The key takeaway is that while formal methods are costly, they are indispensable for systems where bugs are not an option. Thus, coming to the end of the session. Thank you.